At exactly 2:43 a.m., 3 Ukrainian drones dropped below radar, flying low over occupied territory. Their target, a fuel train deep inside Russian-controlled lines carrying enough diesel to power 2 battalions for a week. What happens next will cripple a critical supply route and expose a fatal flaw in Russia's rear defense. Mission structure includes 5 UAVs. Primary overwatch is conducted by a DJI Mavic 3 recon drone stationed at 8-kilometer standoff. It feeds continuous telemetry and visual on the moving target. 3 FPV quadcopters, Ukrainian-built, carry the strike payloads. A second Mavic is on standby, ready to take over if the lead drone goes down or runs into trouble. All UAVs employed are custom-rigged. None are commercial variants. DJI Mavic 3 reconnaissance platforms deployed in Ukraine are frequently field-modified. Standard units carry the Hasselblad L2D20C camera with a 20-megapixel sensor and up to 28x hybrid zoom. Experimental firmware can extend digital zoom to 56x. Some variants are integrated with FLIR boson thermal cores, enabling thermal imaging and heat signature detection during night operations. Cruise speed averages 42 miles per hour. Maximum flight time reaches 46 minutes. Operational ceiling is approximately 19,685 feet above sea level. Ukrainian-built FPV attack drones are configured for single-direction strike missions. They use 7-inch propellers paired with 2807 class brushless motors, each producing 5.5 pounds of thrust. Flight control is managed by F7 boards running customized Bella flight firmware. These systems exceed 87 miles per hour in terminal dives. Structural stability is retained on high-speed impact. Labeled as cost-effective, these strike UAVs offer a scalable offensive option in modern combat scenarios. Inside the secured command center, 18.6 miles from target, Ukrainian UAV operators monitor thermal imaging feeds. A distinct heat signature forms against the cooler terrain. The DJI Mavic 3's thermal sensor detects temperature differentials as fine as 0.05 degrees within a 656-foot range. Firmware modifications enable the platform to avoid detection by Russian aeroscope systems, which typically locate DJI drones via unencrypted transmissions. The lead reconnaissance operator establishes visual ID on the fuel train via encrypted comms. The thermal feed displays the locomotive's diesel engine, producing a high-intensity heat bloom against the nighttime environment. Target discrimination remains effective under zero-light conditions. Reconnaissance telemetry is transmitted in real time to strike zone units in the command bunker. 3 FPV strike drone operators confirm receipt of targeting data via encrypted channels. Each Ukrainian-built one-way quadcopter is presumed to carry a 5.7 to 13 2-pound shaped charge warhead designed for single-use precision attacks. These warheads employ dual-stage detonation. The primary charge is composed of tungsten alloy-shaped liners, engineered to penetrate up to 0.87 inches of hardened steel, exceeding the 0.39 to 0.59-inch wall thickness of standard Russian fuel tank cars. The focused explosive jet travels at velocities above 30,000 feet per second, breaching the tank shell and initiating ignition temperatures beyond 4,532 degrees. The strike plan relies not only on firepower, but also on timing. Ukrainian intelligence tracked the movement of this specific fuel train for 72 continuous hours. Civilian spotters armed with nothing more than regular smartphones followed the train's route, logged its refueling stops, recorded its average speed, and most critically identified a 15-minute window when it would move beyond the coverage of Russian air defense systems. These partisans, ordinary locals living under occupation, risked everything to transmit the targeting data that made this precision strike possible. Stories like these deserve attention. Drop a comment below. What would you have done in their place? Once the location was confirmed through both visual and electronic means, the first drone operator initiated his sequence. His FPV strike drone, manufactured in Ukraine, began its descent toward the moving train. The drone employs a dual navigation system, GPS, for long-range guidance, then optical tracking during the final leg. In the last 15 seconds, it switches to image recognition mode, locking onto the target using real-time visual data. Each platform serves a distinct role. The Mavic 3 handles continuous surveillance and target designation from a safe standoff. The strike drone executes the attack with speed and precision, but hitting a moving train is no simple task. Traveling at roughly 36 feet per second, it leaves almost no room for operator error. The drone's fixed, digitally stabilized camera transmits live footage directly to the pilot's headset, maintaining visual lock through every final maneuver. The Russian fuel train rolls on unaware. In 30 seconds, it's going to burn. At Iro 2:44, just as the first attack drone begins its final dive toward the target, Russian electronic warfare systems respond. 3 kilometers away, a LER-3 unit mounted on a Kamaz truck chassis is activated. This system is specifically designed to jam GPS and control signals within a 30-kilometer radius. Right within the drone team's operational zone, the Russian crew starts with a full-spectrum jamming tactic, blasting high-power noise across multiple frequency ranges, simultaneously aiming to break the drone's connections, or force them to turn back, giving their artillery a shot. Inside the Ukrainian control room, warning alerts begin flashing. The main frequency link is under heavy interference, but the Ukrainians were ready for this. Their system uses continuous frequency hopping switching communication channels hundreds of times per second, making it nearly impossible for the Russians to lock onto the signal. Both the Mavic recon drones and the attack drones are configured to cycle through 3 different frequency bands at once. This setup is tailored for operating in high-interference combat zones. When the Russian team shifts to spot jamming, zeroing in on the 2.4 GHz band commonly used by commercial drones, the Ukrainian system holds its ground. The Mavic recon drone automatically scans for interference, detects the jammed band, and switches to a clean channel on its own without operator input. Target data continues streaming thanks to AI-enhanced sensors. The operator announces a switch to the backup frequency. The attack drone automatically jumps to the L-band reserve channel. Meanwhile, the main data link keeps distributing the signal across multiple channels, cycling up to 200 times per second, making it nearly impossible for the enemy to jam the connection effectively. The Russian LER-3 operators intensify their electronic warfare pressure. They don't stop at GPS jamming, but escalate to spoofing the navigation system, broadcasting fake satellite signals to mislead the drone off its course. But the Ukrainian drone is prepared. Inside the inertial measurement unit, a sealed system of motion and rotation sensors quickly detects that the GPS signal doesn't match the drone's actual flight path. The system immediately shuts off GPS and switches to flight mode based entirely on motion tracking. In the drone's control, computer sensors continue recording every change in velocity, flight direction, and tilt. This is a self-contained navigation system. It doesn't rely on external signals and cannot be jammed or spoofed. By combining both navigation methods, the drone stays locked on its target path even if GPS is cut. The operator reports that the GPS signal is degrading. He manually switches to inertial navigation. On the screen, the drone keeps moving forward, slicing through the dense electronic interference. The targeting system now switches to visual identification. The drone scans the front of the railcar, searching for fixed structural features to stay locked on, despite the train rocking along the tracks. The onboard software has been trained to recognize Russian fuel tank cars from their outer shape to specific technical details. As it enters the final attack phase, the operator reports switching to autonomous mode. From this point, the drone's onboard computer takes full control. It precisely identifies the fuel car, selects the optimal impact point, and carries out the strike without any further input. If that strike and precision blew you away, hit the like. This is modern warfare in motion. The Russians may have jammed one channel, but they can't stop what's coming. At exactly 02:44 hours and 30 seconds, the Ukrainian strike drone hits the third fuel tanker car. The 2.6 kilogram shaped charge warhead detonates on contact, led by a tungsten steel alloy penetrator engineered for optimized armor-piercing performance. The penetrator drills clean through the tanker's 12mm steel shell, creating a precise thermal breach immediately followed by the ignition of the secondary incendiary charge inside the pressurized fuel chamber. Temperatures exceed 2,500 degrees Celsius, instantly vaporizing hundreds of gallons of diesel. Internal pressure spikes cause structural failure, breaching all containment. Infrared feed from the DJI Mavic reconnaissance platform captures the rapid expansion of the heat plume. The operator confirms a direct hit on Car 3. Thermal imagery updates in real time, showing fire propagation accelerating along the train structure. The target is ablaze. Secondary explosions begin. Heat and overpressure impact neighboring cars. The interlinked ventilation system, originally designed to equalize pressure during fuel loading, now serves as an ideal conduit for flame travel in a vapor-rich environment. Within the first 15 seconds, fuel vapors in cars 2 and 4 ignite. The Russian locomotive engineer immediately engages the emergency brake. The train comes to a full stop, locked in place. What was once a mobile target is now stationary, exposed, and unable to maneuver. Navigational data confirms 2 remaining drones are approaching in parallel formation at low altitude, preparing to complete the strike. At 2:45 a.m., sharp as the fire from the first drone, impact continues to burn uncontrollably. The second and third Ukrainian drone teams commence their synchronized follow-up assaults. The immobilized fuel train, now fully exposed, presents no resistance. The second drone operator selects the 6th tanker in the convoy, still structurally intact, despite its proximity to the initial blast zone. The quadcopter produced in Ukraine advances from the southeast, using the rising smoke and fire to mask its movement. Thermal optics on board detect the distinct cool signature of the untouched car. The targeting processor adjusts for the thermal interference coming off nearby flames and keeps the weapon on course. A DJI Mavic recon drone remains overhead, supplying real-time visuals and marking priority targets. Its AI-assisted sensors automatically scan for viable fuel cars, identifying car 6 as next. The recon drone's heat imaging maintains full visibility through the smoke layer. The strike operator reports contact. The drone enters its terminal descent. Upon impact, the warhead, carrying a 5.7-pound shaped charge, pierces the steel wall of the tanker, breaching the hull instantly. The high-pressure diesel fuel inside combusts, releasing over 152,000 pounds of fuel into the Firestorm. The explosion merges with surrounding flames, expanding the inferno across 4 tankers. The resulting temperatures exceed 5,000 degrees Fahrenheit. Pressure from the blast damages the rail structure and containers around the target zone. Simultaneously, the third drone team shifts focus to the rear. 2 fuel cars remain untouched. The drone takes a westward path, targeting the 8th and final tanker. The system locks on. Final dive initiated. The outcome mirrors the previous strike: direct hit, fuel detonation, and complete structural failure. Another massive fireball connects to the growing blaze. Total fuel consumed across all impacts, approximately 1.2 million pounds in CS. The sustained firestorm generates intense thermal lift, drawing air into its base and forcing smoke and flame upwards more than 700 feet. The plume is visible in infrared from satellite altitude. The railway line is no longer usable. Steel tracks have buckled under heat. Wooden rail ties are incinerated. Shrapnel from the tankers is spread across the area, disabling the surrounding route. Field estimates suggest repairs may take 3 to 5 weeks, assuming no further drone attacks delay restoration efforts. The operation was swift, precise, and irreversible. What began as a single drone strike escalated into a calculated series of hits that not only ignited over 1 million pounds of fuel, but crippled one of the key logistical routes deep behind Russian lines. These weren't just explosions. They were disruptions to supply chains, delays to reinforcements, and a clear message: no place is out of reach. If this breakdown gave you a new perspective on how drone warfare is reshaping the battlefield, let us know in the comments. Got questions, theories, or a mission you want covered next? We read every one. And if you're into real-world operations, no fluff, no hype, consider subscribing. We've got more mission-level debriefs coming your way. Thanks for watching, stay sharp, and we'll see you in the next mission debrief.